Thanks, Dennis. As Dennis mentioned, my name is Mike Cyros, and my role is sales support and business development for Euresys here in North America. Joining with me today on this webcast is Marc. He's the CEO of the Euresys Group. He's currently based in Singapore, so we're really appreciative that Marc could join us. It's now midnight time for him. Also joining us is Paulo Possa. Paulo is based at our headquarters in Belgium and is a senior hardware engineer with a particular focus in FPGA. And finally, a special guest that's joined us, Denaro, who's a senior engineer at the company Vision Research, which is one of the Amatech companies based in New Jersey. You'll hear more from Lee later on in this webcast. So to take you through CoaXPress-over-Fiber, we've got 7 sections here in terms of our presentation today. I'm going to give a very quick introduction to the company, a quick review, which can serve as a rapid primer on CoaXPress and its benefits. Then we'll get into details of extending the benefits of CoaXPress using fiber. We'll give you some use case examples and then actually a demonstration, live demonstration of the technology and how it's working. And then we'll dive into technical details into how this is actually implemented. And time allowing at the end, we would love to take and answer any questions for you. So to kick this off, just gut feeling from you, which frame grabber company first comes to mind? If you were thinking about a new project and knew that you realized that you needed a frame grabber, which company of those that are listed there comes initially to mind? I'll give you a few seconds to click on your choice there. I'll give us a little bit of guidance for the presentation today. Okay, I see some answers are coming in. So moving on from there, let's take a look at what the audience is seeing. Well, I'm happy to see good recognition for Euresys, but also Matrox and Teledyne DALSA. The reason for mentioning this is the technology that we're talking about today, it's not unique or specific to Euresys. It's a technology that can be adopted by the industry. It's the next step beyond CXP12, which is what we're discussing here today. So who is Euresys? We are now in our 31st year of business. We're headquartered in Belgium, and recently during this year, it turned out the pandemic timing was remarkably good for us. We managed to move our headquarters into a new, larger facility. We're in the French-speaking area of Liège in Belgium, not too far from the German border, which is where our headquarters are. We have 6 offices globally spanning the time zones, Europe, Asia, and here in North America. We have 70 employees globally spread. Nearly 50% of those are based in R&D, so we're a very technology-focused company. And we serve the market both directly and also in partnership with many global partners that you see around the globe there. In terms of products that Euresys provides, yes, here we're talking about frame grabbers, which are image acquisition devices for acquiring high-speed image data from digital cameras into a PC. We also provide IP cores, which are ready-made, pre-compiled, ready-to-go logic for FPGAs to implement standards into cameras or frame grabbers, such as CoaXPress or USB 3 Vision or 10 gig eVision. We also provide a very rich library of machine vision software tools, and we also are in the market of video servers, acquiring data from HDMI, for example, and transmitting that using the ONVIF standard over standard Ethernet protocol, so kind of a specialty product that we make there as well. As mentioned, 50% of our employees work in R&D, and we have an aim to invest 20% of our revenue every year back into R&D. Our goal is introducing 3 new products launched every year. Today, we're going to be showing you the 3rd one that's been launched this year. We are also very active in the global standards organization. So much of what we're explaining here today is also something that we're doing actively within the standards organization to promote this technology for global adoption. Just to give you a quick at a glance, last year we produced and sold over 30,000 frame grabbers, and in terms of software, we sell in excess of 50,000 software licenses per year. So just to give you a sense of the scale and scope of our business. Most importantly, from all of those regions globally, there's a dedicated team of sales and support partners that are closely linked. And when you have a relationship with Euresys, it's not just with a company and a product, it's with many of these individuals that you see here on the screen. So now let me just introduce briefly what CoaXPress is so that we can then set the stage and jump into the next layers of technology. So what is CoaXPress? We'd like to argue that it is by far the world's leading standard for high-speed imaging. You can think of it simply as a high-speed camera to host image data transport, and at the same time, it can handle command and control and power. I'll explain that in a little bit more detail, but you'll find it used in machine vision, medical imaging, life sciences, for sure broadcast, and defense markets. Finally, you'll notice in many discussions that people commonly abbreviate CoaXPress as CXP. So I just wanted to point that out. Those terms are often used interchangeably. So what's in a name? CoaXPress combines standard, off-the-shelf, regularly available coaxial cable together with a high-speed serial deserializer technology where we can move a huge amount of data serially over a single wire. If you put those two pieces together, you have coax for the cable piece and express for the data piece. Put it together and you end up with CoaXPress. So I'm pronouncing it as CoaXPress. Sometimes you'll hear people pronounce it as CoaXPress, but the preferred pronunciation normally is CoaXPress. As I argued, it is the best standard for the machine vision industry. It was first demonstrated in 2008. The first official release was 9 years ago in 2011. The latest version released last year is CoaXPress 2.0, which brings the CXP12 speed. I mentioned the standards. It's important to note that this is a global published standard hosted by JIA, the Japan Industrial Imaging Association, and it was adopted as a global standard via the G3 Alliance, which is a global alliance with JIA, the EMVA in Europe, and the AIA, Automated Imaging Association, here in North America. So anybody who's a member of those, any of those member organizations has full access to the CoaXPress standard. An important point to recognize here is very broad market adoption. We have more than 50 companies supplying CoaXPress products available in the market today. So you can see it's not just 1 or 2 specialty companies, it's widely adopted in our industry. So you see collections of frame grabbers, cameras, and accessories, things such as cables, extenders, and repeaters. So there are many active suppliers here. Again, the goal is to move data very quickly. So with the current iteration of the standard, you can move up to 12.5 gigabits per second over a single coaxial cable. So translate gigabits per second into actual image data. That's in excess already of 1 gigabyte per second over a single coax cable. And on that same cable, you have simultaneous communications and control, real-time event signaling, and triggering and so forth. And you can provide plenty of power to the camera over the same cable. Finally, you can easily combine multiple cables in cameras and frame grabbers to significantly increase the bandwidth to several gigabytes per second. Just in terms of comparison, you can see the progression of bandwidth offerings from GigE vision. There was a leap up to USB 3 vision. Just in terms of moving 4 megapixel images under camera link, there was a boost to go to 180 frames per second. And then finally, with today's now commonly available quad CXP12 cameras, you can move more than 1,200 frames per second. Long cable support is an important feature also of CoaXPress. So you can see here in various combinations and speed ratings, you can achieve up to a 100-meter cable run using standard available coaxial cable. Finally, there's two types of connectors that are used. So we have quite robust connections on the frame grabbers and on the camera side. So these cables have a positive latching mechanism to a DIN 1023 style connector, or a bayonet style, which is used like a traditional BNC, but known as a micro BNC. That's a positive lock connection to the frame grabber and the camera that's supporting CXP12 speeds. One of the most important features of CoaXPress is its real-time, very low latency deterministic triggering capability. That's really important in machine vision, obviously, where you want an accurate representation of a part and place, or a web encoder to trigger the camera precisely to the images being acquired. So these triggers can occur with an accuracy of plus or minus microseconds. So you can be very precise in triggering with CoaXPress, again, over that same cable. Finally, there's a huge amount of standardization behind CoaXPress with the underlying, or I should say, overlying GennyCam standard. With GennyCam, the camera is auto-discoverable. It powers up. It communicates immediately with the frame grabber by downloading an XML file that allows the frame grabber to understand what camera or cameras are connected to it and configure itself automatically to work with that camera. That's a great new standardization feature that was brought by GennyCam. And just to give you two quick glimpses of typical application use cases of CoaXPress, here you see a complicated system that's used in a multi-stage 3D virtual reality or stadium type imaging application where you're acquiring video, high-speed video from multiple cameras and then feeding that data in real time directly to GPUs for processing and volumetric image calculation. So this illustrates the ability to synchronize cameras very precisely using CoaXPress. And then on the other end of the spectrum is CoaXPress is also commonly used in embedded applications. So in the top left picture, you see a CoaXPress low-profile frame grabber used in an NVIDIA Xavier that has a PCI Express slot available. And then on the lower left, you see also one of our frame grabbers used in a PCIe 104 industrial ruggedized chassis with CoaXPress. So many combinations are possible. I'll leave you with this slide to summarize the benefits at a glance of CoaXPress. And finally, a second polling question I'd like to ask before we move on. Curious to learn, what camera interfaces have you used in your applications before? You'll see listed there several different ones, and it's a multiple choice, so you can click on the ones that you've had actual experience with. You'll see GigE vision followed by 5 and 10 GigE vision, or even now 25 GigE vision. So just curious to get a sense of the positioning of how many people have used CoaXPress versus the other interfaces there. And again, this one's multiple choice. Okay, so having a look at the results, you can see it's very broadly spread. And interestingly enough, quite a few audience members out there using CameraLink, which is still, it's the oldest remaining and broadest adopted digital interface standard, but you can see that CoaXPress and GigE-Vision are the other two dominant interfaces in the market. So thank you for your input on that. That represents generally our feeling, but we see that for sure CoaXPress and now 10 GigE-Vision are really gaining on CameraLink is our observation in the market. So thanks for your feedback on that. So with that, I'd now like to hand over to Marc Damhaut. Again, Marc is the CEO of the Euresys Group, and he's going to now introduce the technology and the reasoning behind CoaXPress-over-Fiber to give you a real glimpse of what's coming next beyond CXP12. So over to you, Marc.
Thank you very much. Thank you very much, Mike, for this nice introduction about CoaXPress. Let's jump into the core of the presentation now, and we will be talking about CoaXPress-over-Fiber, or more precisely, what's next beyond the CXP12. So this is a table, a slide that shows you our current CoaXLink product range. CoaXLink is the name of our CoaXPress frame grabber. So they range from CXP6 cards on the left to CXP12 cards on the right. We have horizontally the different kinds of PCI Express buses that we support. The most popular card in that range today is the CoaXLink Quad G3. It's right in the middle. It's quad the CXP6 frame grabbers, and that shows you that there are still a lot of high-end CXP6 applications today. 4 times CXP6 means a total data rate of 2,500 megabytes per second. The number 2 product is the CoaXLink Octo. The CoaXLink Octo is 8 CXP6 connections. And the fastest growing product for us this year in 2020 is our CXP12 frame grabber, the CoaXLink Quad CXP12. So that's an indication that CoaXPress is used for high-end application, I would say high bandwidth applications. That's a photo of the CoaXLink Quad CXP12 here. That's a 4-connection CoaXPress CXP12 frame grabber. And as Mike explained, you can see the 4 HD BNC frame grabbers, the 4 HD BNC connectors on the bracket of the frame grabber. Let's keep that picture in mind. We'll come back to it later. So the CoaXLink CXP12 was introduced 2 years ago already on the market. Along with the CoaXLink Octo, they are the most important cards in our product range. They provide each a total bandwidth of 50 gigabit per second. This really shows that there is a constant need for more bandwidth as the CoaXPress standard is serving the high-end side of the market. The CoaXLink Quad CXP12 was introduced 2 years ago, and already at that time at Euresys, we started to wonder what will come next after CXP12. What are we going to do? What can we do to satisfy the demand for more bandwidth? We thought about CXP25, and there's certainly a possibility to run 25 gigabit per second transmission over a coaxial cable. One of the problems would have been that the cables, which are probably around 40 meters now, maximum length with CXP12, would have gotten shorter and shorter the higher the speed. And after thinking about different solutions, it became clear that going further would require transmission over fiber optics. So we started to look around and try to find ways to carry CoaXPress data, CoaXPress signals over fiber optics. And we really innovated here. Our team at Sensor2Image, Sensor2Image is Euresys subsidiary in Germany. Our team at Sensor2Image 2 years ago has designed a way to run the CoaXPress protocol as it is, completely unmodified, over a standard Ethernet connection. So we have found a way, and we'll talk about this more in the rest of the presentation. We have found a way to use standard electronics, connectors, IP, cables designed for Ethernet. So CoaXPress-over-Fiber will be able to use this standard equipment. But the protocol is CoaXPress, not Ethernet. So we are not running Ethernet. We are not getting closer to GigaVision. We absolutely want to keep the CoaXPress protocol as it is because we are very happy with the results and the features of the CoaXPress protocol. This in particular, before you ask, in particular, this means that with CoaXPress-over-Fiber, Ethernet routers, for example, and switches will not work because they rely on a higher level of communication. Very important. By using Ethernet, we will benefit from the low-cost standard Ethernet equipment, connectors, and cables. And this is exactly what we were looking for. With a camera link, even with a CoaXPress, we have relied over dedicated hardware, dedicated interfaces. With CoaXPress-over-Fiber, we looked for a way to rely on standard low-cost equipment to carry data, images between devices. As you know, and Mike has talked about this, the CoaXPress standard is hosted by the GIA. Ethernet is defined by IEEE standards. So for CoaXPress-over-Fiber, we rely on two very strong standards. By working with Ethernet hardware, we will benefit for free of the evolution of Ethernet towards higher bandwidth. Today, with a normal RJ45 connector connected to your PC, you probably have 1000 base T, which is 1 gigabit Ethernet. 10 gigabit Ethernet is here today, but in data centers, 40G, 100G, so 100 gigabit per second and 200G Ethernet are there already. There's equipment using this speed, and 400G, 400 gigabyte per second is coming. Just to put this into perspective, this is where we are today. So on the left of this graph, we see the bandwidth that we can reach with the 4 CXP6 connections. So 4 times 6 is 25 gigabit per second raw bandwidth. With 4 12 gigabit per second connection, we have 50 gigabit per second total bandwidth, raw bandwidth, which corresponds to 40 gigabit per second net bandwidth. This is where we stand with CoaXPress-over-Fiber today. We can run 4 connection at 10G Ethernet with CoaXPress-over-Fiber, but we have a very clear path for evolution towards higher bandwidth. With CoaXPress-over-Fiber, we will quickly be able to move towards 100 gigabit per second, 200, and even 400 gigabit per second connections. You have understood, I think, we are going to move to fiber. And using fiber optics, I mean, will be a big change, but we believe that that's the right move. Fiber optics are definitely better than copper cables for all our applications. Using fiber optics, we'll get access to higher, virtually unlimited bandwidth. We'll have access to virtually unlimited distance, so much longer cables without so many problems related to cable length. With fiber optics, we also have a complete immunity to electrical noise. So no interference, for example, with electrical equipment on the factory floor. Fiber cables are also significantly lighter than any kind of coaxial cable. It also takes much less energy to transfer light and to send light over optical fibers than it takes to send electricity over coaxial cables. So using fibers will also reduce the overhead power consumption of the systems. There's one drawback, is that there's no such thing as a power over fiber. So we are used to using a POCL, a PoE, POCXP, so power over cables with all our machine vision standards. That will not be possible with fiber optics. Of course, it will still be possible to have a separate cable to power the camera, if that's what we are talking about, but most likely we will have to power the devices, the cameras, locally. So this is the first product that we introduced, which is compatible with the CoaXPress-over-Fiber standard. We call it the CoaXLink QSFP Plus because we have chosen to use a QSFP Plus port compliant with 40 gigabit per second optical modules with this frame grabber. So if you watch closely, you can see that this card is exactly a CoaXLink Quad CXP12, except that we have replaced the 4 HDBNC connectors by a QSFP Plus cage. This is a QSFP Plus slot that you see at the bottom of the bracket. I will explain what a slot is. You can see here, this is a cage, a slot which is actually empty, and I'm going to explain how to use it. QSFP Plus means Quad SFP Plus, so 4 times SFP Plus. And SFP, actually an SFP modules stands for a Small Form-factor Pluggable module. This is the kind of module which is used in data communication. For example, in data center, it's a compact network interface which is used in this environment. QSFP Plus and the higher bandwidth versions like QSFP 28 or even QSFP 56 are widely used today in data centers. What are the advantages of using this kind of transceiver module? The advantage of using this module compared to fixed interfaces is that the ports can be equipped with different kinds of transceivers. So compatible with QSFP Plus, we have a variety of transmitter and receivers that are available and which will be suitable for different kinds of applications, different kind of optical fiber, depending on the application. So you see the photo of the CoaXLink QSFP Plus at the bottom right. Here we have on the left the photo of a transceiver. The transceiver is the module that converts the electrical signals into light. And we are going to insert the transceiver into the CoaXLink QSFP Plus, into the QSFP Plus cage. A word about the bandwidth here is actually very easy. QSFP Plus provides a bandwidth of 4 times 10 gigabit per second, and because of the overhead and the encoding of the signal, this is actually exactly the same bandwidth as we had with 4 CXP12 connections. These are 2 examples of optical transceivers that we have tested today with our CoaXLink QSFP Plus. So on the left, we have a 40G base ER4 QSFP Plus transceiver. On the right, we have an SR4 transceiver. So I'm going to detail them a little bit. That transceiver here will be suitable for machine applications. It uses an MTP-MPO connector. So you see the photo on the middle is the MTP-MPO connector. Actually, in this cable here, you see on the right, there are 12 fiber optics. We use 4 to transfer data in one direction and 4 to transfer data in the other direction. With this kind of fiber and this kind of transceiver, we can have access to a maximum of 150 meters of fiber. So this is more than enough for all our machine vision applications. I ask you to, after this presentation, to copy 40G base SR4 QSFP plus transceiver into Google search window, and you will see that there are plenty of options available. You can buy the transceivers, you can buy the AOC, which is the all complete active optical cable, and you will see that the prices are really affordable. Why? Because this is the option which is used for data communication in data centers, and this is a kind of device which is really available today, mass-produced and easy to purchase. Another type of transceiver that we have tested and that works great, and we are going to have a demonstration later of that transceiver. It uses a single mode fiber with an LC duplex fiber connector. So in this case, we have two fibers, and you see in the middle the duplex connector with the two fibers. With this kind of configuration, the maximum length is 40 kilometers. So you can quickly see that we target a completely different range of application. But this means that we have access with the same product, the same camera, the same frame grabber to different kinds of application depending on the transceiver we are going to use. So that's a quick introduction of CoaXPress-over-Fiber, the current status, the CoaXLink QSFP Plus, and the type of transceivers that we have tested so far with this card. I have introduced, and we have introduced quickly the benefits of the CoaXPress-over-Fiber and moving from copper into fiber. So our next polling question will be, which benefit of the CoaXPress-over-Fiber would be the most useful to you? So it could be long distance. We talked about 40 kilometer, very high bandwidth, low cost, because we use mass-produced transceivers used in data centers, electrical immunity, the fact that the cables are lightweight. Please, I gave you a few seconds to think about which of these features would be most useful to you. So let's check the results. So the very high bandwidth, I mean, as we guessed at the beginning of the presentation, CoaXPress is used for high bandwidth application, but we see that electrical immunity and long distance are also very interesting features of the new CoaXPress-over-Fiber standard. Thank you. Back to you, Mike, for the following part of the presentation.
Thanks, Marc, and thanks everybody for the feedback on that polling question. Interesting for us to see that it's our experience that high bandwidth is the primary desired feature and benefit of CoaXPress-over-Fiber. Just to trigger and stimulate your ideas of these applications, just highlight several use cases where we're already starting to explore CoaXPress-over-Fiber. AOI and the introduction of 3D imaging now, where you're, for example, talking about high bandwidth, moving real-time color data along with perhaps a processed height image map coming from a 3D sensor significantly increases the amount of volume that a camera or device or a 3D imager needs to deliver back to the host. That's a great use case. Another one, of course, is driving much of our industry is going from LCD to OLED inspection to the next generation of flat panels. Every time you, quote, double the resolution in both X and Y, you're producing 4 times more image data. So the increase on bandwidth requirements is exponential in that space. So they're constantly pushing our industry for higher resolution. Print inspection, for example, continuous web, where you have multiple line scan cameras or TDI cameras stretched across a web to do inspection. These require quite long cables, so it's relatively easy to move a single fiber cable out to each camera, and again speaks to overall bandwidth. Marc mentioned noisy environments. This really is a serious issue in, for example, in heavy robotics type applications where you've got lots of motors generating lots of electromagnetic interference, and you really need the imaging system to be tolerant to that. And that's a big advantage for fiber in that case. Also, for those familiar with the many stadium imaging applications, you have a very large area with multiple cameras to feed. So you could, for example, feed a pod of, say, 4 or 8 cameras locally in a section, combine those onto fiber, transfer that fiber directly back to the frame grabber. And as CoaXPress-over-Fiber accessories start to hit the market, that will become easily possible as well. And then finally, one of our favorite applications that really highlights the high bandwidth topic. So that's why I was really glad to see that that is everyone's or the most popular concern. Is a great example of the Vision Research Phantom S990 camera. This is a camera that provides up to 8 gigapixels per second. So that's 80 gigabits per second of data. Think of it as full 4K television resolution, so 4K by 2304 pixels, running at not 30, not 60, but 938 frames per second at very high resolution. Currently, this camera is using 16 copper CXP connections to achieve that level of bandwidth. And you could just imagine the impact that CoaXPress-over-Fiber is going to have on this type of application. So with that, I'd like to bridge now to a live demonstration and have the opportunity to introduce a special guest that has joined us for this webcast. Introduced at the beginning. His name is Denaro. He's a senior engineer working for the company that I mentioned on the previous slide, Vision Research. It's one of the Amatech companies, and he's a senior engineer working on a project currently that's in the process of implementing CoaXPress-over-Fiber. So I'd like to hand over to Lee now to further introduce himself and explain what he's doing and give you a demonstration.
Yeah, thanks so much, Mike. Again, my name is Lee Denaro. I'm a systems engineer and senior test engineer here at Vision Research. So I'm responsible for the overall systems design of our new CoaXPress-over-Fiber camera model that I want to show you guys a first look at today. I'm also the test applications architect here at Vision Research for CXP and our standard cameras. And I've been an active participant in the CXP working groups for a few years now as we get into that market. So just a little bit about the company, Vision Research. So we are the manufacturers of the Phantom high-speed camera brand. So we like to think of ourselves as the industry leader in high-speed imaging. We design and manufacture our cameras in Romania and New Jersey. And a little history, we actually started developing high-speed film cameras here in Wayne, New Jersey in 1950. And it wasn't until 1999 that we transitioned into a digital solution with our standard cameras, our standard high-speed digital cameras. And so just to explain a little bit of that, historically, since that 1999 release, our cameras are a high-speed sensor that stream the data directly into RAM that is located in the camera itself. And then once those frames are in RAM, we can either stream that off at a later time via like a 1G or 10G interface to a PC or to some hard drive type hardware that we also sell as an accessory to the camera. But the camera has always been the location of the data as well as the creation of the data through the high-speed sensors. So this is used all over the place in defense, manufacturing, scientific research. You saw some of the pictures of the automotive high-speed crashes. You've probably seen some of our shots not even knowing about it in your favorite high-speed slow-mo, film, whether it's from a movie or from a replay of a sports game. So we're kind of all over the place in the high-speed world. But since 2017, we've been trying to expand into the machine vision world. So the products that I want to focus on now, you got a little bit of a flavor of that was at S990 on this high bandwidth platform. So that platform with the 16 links can output up to 9 gigapixels or gigabytes per second. So we have a few sensors that fit into that. Mike mentioned the 4K sensor that goes about 1,000 frames a second. We also have a 4 megapixel and a 1 megapixel camera sensor that goes that will require that high bandwidth platform. So what that platform allows us to do is we split 16 links, CXP6 links, across 4 different banks. What that means on the application side is each bank is mapped as a separate camera. So we actually split that image into quarters, and we stream each quarter of an image to a separate frame grabber or a separate bank in the PC. Then it's up to the application side to stitch that image back together and then do its analysis or record it or whatever the application calls for. But basically, in order to get our high speed, all this data creation that's happening with the sensor, we need to split it over 4 banks in the current CXP6 coax model that we have. So one of the recent applications that we have is with NASA. And their mobile launcher platform. And so what this is the shuttle launch pad, basically. There's 2 of them, and each one of them is has a lot of dozens of high-speed cameras at the moment. But right now, they're high-speed film cameras. And so they're looking to upgrade that into the digital world. So they love the sensor. The 4K image resolution is exactly what they need, 1,000 frames per second. It's creating the data and allowing them for extremely precise target tracking as the shuttles will get launched. But the interface from the sensor to the computer isn't great in the current in the CoaXPress over copper, basically. Problem at NASA has a lot to do with the distance. So their base is about somewhere around 7 to 8 kilometers from the actual launch site, which CoaXPress over copper cannot work with, right? So they need some sort of fiber solution. At the moment, there are some fiber translators or repeaters that can take a bank of 4 CXP6 CoaXPress data and translate that into fiber and then and move that across. But those are expensive. You need 4 per every camera because, again, we have 4 banks per camera. That gets really expensive. They're power hungry, and it's very bulky. So the whole system becomes this very large acquisition system. So again, they love the sensor, but they really wanted a better interface. And so when Euresys came to us and said, hey, we're working on this CoaXPress-over-Fiber COF bridge, would you be interested? We jumped at the opportunity. So the idea of being able to bring all of that extra work that's going on with the repeaters, the extra power, and simplifying that greatly and bringing that into the camera fit us perfectly. So it's going to reduce the system complexity for NASA, but really for anybody. The cables there's only 2 cables at the moment instead of 16, and the power and EMI isolation is much, much better. So again, working closely with Euresys has been a huge help for us. That allowed us to be an early adopter of the COF standard, be able to be a part of that as we are working to move that into the standard like we've been talking about. They are a technology leader in this, and so just working with them has brought us a lot of good benefits for sure. So I just wanted to show you what we're calling the S991. So it's our next generation of that S990. So this is going to be one of the industry's first coax link over fiber camera models. It's our first release of it. And it's the same sensor platform as the S990. It's that 4K sensor. But we've upgraded the FPGA, and we've upgraded our core to be a CXP12 core for Euresys and implementing their COF bridge. So taking it from our 16 CXP6 link interface and turning that into CXP12, which can give us twice the bandwidth with just an upgraded core. But then also implementing the fiber allows us to have only 2 QSFP plus banks, which again is equivalent to a quad CXP12 bank. The mechanical design is updated. It also has lens control for EOS lenses, shutter for black reference, a bunch of GPIO, and timestamp syncing, et cetera, et cetera. So without further ado, I'm going to move my camera to show you. I have it running next to me. So bear with me as I reposition my camera. to show you guys what's going on. So this is the S991. You can kind of see here off the back of the camera, here's the two transceivers going into the side horizontally into the camera. So these are the multi-mode transceivers, the MPO connections. We also tested it with the those 40-kilometer high power transceivers for single mode, and they work the same. The great thing, just like Marc was saying, there's no change in the firmware on the camera or in the frame grabber. It's just a matter of picking the transceiver that you want that works with your application. But instead of 16 heavy copper cables, we have these nice lightweight fiber cables that go directly into the two frame grabbers. I don't know if you can see them, but the two QSFP plus frame grabbers, coax link frame grabbers from Euresys that they've recently released. So that's what we've been working with them. So I'm going to leave that here. And then I want to show you just a short demonstration of what we can stream. Just to let you know, so this is an early look. It's a work in progress. We're still working on getting the sensor images off of the camera. But so what we've done, what you'll be seeing in this demonstration is a test pattern that gets generated on the FPGA in the camera, split across the two banks, like I was mentioning, streamed to the fiber frame grabbers, and then shown on the screen. So what you should see is, you're not going to see the lensed image, but you'll see a moving test pattern, but it's going to be split across two streams. So if you can see my screen, you'll see these two devices here. These are the QSFP plus frame grabbers, and they're mapping it as two separate cameras. So if I start the stream on those, you should see, two moving vertical test patterns. So this is data that's being created on the camera itself and pushing itself across the fiber into the fiber frame grabber. So it's our first look at what high-speed streaming in this COF application space will look like for us. So this is huge for us to be able to take it away from the 16 copper cables, upgrade the speeds to a CXP12 bandwidth, and move it into the COF interface. Allows us to have an easier connection for us and our users, and specifically in this NASA project, allow for things like a 40-kilometer distance between the PC and the frame grabber. So those are huge improvements to the application. I know it's something that we're really excited about, and our customers are going to be really excited about too.
Thanks, Lee. Thanks for that great demonstration and explanation of the technology you're showing there. For the final segment of our webcast, I'd like to now hand over to Paulo, where Paulo is our active working member on the CoaXPress working group in the standards committee, and has intimate knowledge with how this is actually implemented. So he can go into some more details for you to explain that. So over to you, Paulo.
Thank you, Mike. So I'm Paulo Possa from Euresys. In this part of the presentation, I will talk about the motivations to standardize CoaXPress-over-Fiber. I will also talk how does CoaXPress-over-Fiber compare to other standards, and finally I will explain these challenges to make CoaXPress-over-Fiber a successful standard. So firstly, I would like to say that CoaXPress-over-Fiber is not the first solution using fiber cables in machine vision applications. There are already a few existing solutions for machine vision. One example is the Microtron Euresys fiber, that it's a machine vision camera employing fiber cables. It's important to say here that this is a proprietary solution. It means that it is not, the solution is not associated to any international standard. This is the same case of converter and extender solutions that we have in the market. these devices can be used for as Lee explained. So we can have some converters to convert CoaXPress coax solutions to fiber, and then back to coax at the in each side. And these solutions are also proprietary, and they add cost overhead. There are also some examples of existing standards like Hotaru or OPTC link that are Japanese solutions, but they are not really international adapted standards. Finally, we have the Camera Link HS, that is an international standard and supports fiber cables. The problem with these standards like Hotaru, OPTC link, and Camera Link HS is that even being in the market for a number of years already, there are not a lot of products using these standards. So this makes these solutions very restrict to a small market. So this is why we need a new international standard to trigger much wider adoption and to bring interface costs down. We can bring costs down with a larger diversity of products and manufacturers, and also by employing standard available cables and connectors. And by using the CoaXPress protocol, that it's already a very successful standard, we can take the advantage of having more than 50 manufacturers producing CoaXPress products to enlarge this diversity of products employing the new standard. So regarding the standardization itself, as Marc explained, Euresys has developed a mechanism to map CoaXPress protocol into an Internet physical layer to address the increasing demand for long distances and higher bandwidths. As Euresys doesn't produce any camera, we are in a good position to propose a new standard that can be adopted by frame grabber and camera makers without any conflict of interest. So back in 2018, we proposed to GIA to create a CoaXPress-over-Fiber specification based on this mapping mechanism. GIA and the CoaXPress Technical Committee accepted the proposal, and in May 2020, we submitted the first draft of the CoaXPress-over-Fiber specification. 1 month ago, end of October, we submitted the release candidate, and it's already scheduled to be made available to public in January 2021. As the CoaXPress-over-Fiber specification covers the mapping mechanism, GIA also published an optical interface guideline to cover the transmission medium components. So now we have the CoaXPress specification that covers the communication protocol, the CoaXPress-over-Fiber specification that covers the mapping mechanism, and the optical interface guideline covering connectors and cables. So to accelerate the development of products employing CoaXPress-over-Fiber, Sense2Image is working on bridge IPs to perform the mapping mechanism that is defined on CoaXPress-over-Fiber. It's important to highlight here that these bridges are generic and can be used along CoaXPress cores from other manufacturers. It means that even if you have your own CoaXPress core, you will be able to interface it to the sense-to-image bridge IPs. Here I can also talk a little bit about the link architecture. So how the CoaXPress-over-Fiber works. We have here we can have here a non-modified CoaXPress core associated to a CoaXPress-over-Fiber bridge that maps the CoaXPress protocol to a XGMI interface. XGMI stands for 10 gigabit media independent interface. That is the entry point of the Ethernet physical layer. Once we reach the Ethernet physical layer, all components being used are standard and available Ethernet components. From the PHY itself, from the physical layer itself, that can be found as an IP to the transceivers and cables. Everything it's a standard available Ethernet components, and all these components become transparent to the CoaXPress cores. So how do CoaXPress and CoaXPress-over-Fiber compare to other interface standards? CoaXPress is a successful standard because of a combination of features. It has a high bandwidth, it has data transfer with low latency, it has high stability and reliability. I also would like to include here a very low trigger jitter that makes CoaXPress applications very deterministic, which are important in line scan applications and high frame rate applications as well. And CoaXPress-over-Fiber will keep all these advantages because the mapping mechanism it's 100% compliant with the CoaXPress specification. And from the application point of view, it will have exactly the same behavior as a regular coax-based application. Comparing CoaXPress-over-Fiber, CoaXPress and CoaXPress-over-Fiber with GigiVision. So GigiVision is also a very successful and reliable international standard, but do some limitations make it harder to employ GigiVision cameras in high-end applications. So one of these limitations is the bandwidth, because CoaXPress natively supports link aggregation to multiply the bandwidth. So we can multiply the bandwidth by link aggregation, and this link aggregation is very complex for GigiVision applications. Also, we have the stability, because CoaXPress data package management is handled in a dedicated hardware, so without loading the host CPU. And in GigiVision, we have this done by the driver, which can significantly load the host PC, especially with multi-camera applications and high bandwidth applications. So the challenge is to make CoaXPress-over-Fiber successful standard is, first of all, make CoaXPress-over-Fiber become a standard. it's ongoing work, and as I said before, it's the release candidate is already scheduled to be published next year, beginning of the next year. Another point is to motivate the acceptance of fiber optics by the market. Here, I think we don't have much choices because fiber optics are the only available solutions for longer cables and higher bandwidths. And final point is some applications will require ruggedized connectors and cables, even if Ethernet connectors are quite reliable. They are not ruggedized, and this is covered by the optical interface guideline that proposes some ruggedized connectors. So this is my last slide. So the timeline today, we have the prototypes of the CoaXLink QSFP+ available for camera makers for evaluation. We have the sensitive image CoaXPress-over-Fiber bridges available for camera makers for evaluation. We have 3 major camera makers that already started developing cameras with this new standard. And next year, beginning of the next year, we will launch officially CoaXLink QSFP+, and the cameras probably will be launched at 2021. And in the future, we will increase the bandwidth by using QSFP 28 or 56. And that's it. Back to you, Mike.
Thank you, Paulo. Dennis, you could take over for us at this point.
Thank you, Mike. And with that, on behalf of Vision Systems Design, I'd like to thank Mike Cyros, Marc Damhaut, Lee Denaro, Paulo Possa, and everyone in our audience for joining us today. This presentation will be archived within 24 hours and can be accessed from the homepage at visionsystems.com. The slides and some supplemental resources will also be available for download today. You can access these slides and resources by using the resource icon on the bottom toolbar. A reminder email message for the archive will be sent to registrants, complete with a direct link to the archive. If you have any questions about today's presentation, please feel free to email me at dsameka@endeavorb2b.com. We thank you again for joining us today and look forward to providing you with webcasts in the future.